So we have the wheel and the axle, and we're also going to take a look at pulleys. So that's what these notes are about. A wheel is a lever. It's the same thing as a lever. You could see here. It just has a wheel attached to it. There's the wheel here serves as the arm as the lever, and then the axle part. Those are the two components. Something that is important to understand is when you are applying force to the outside of the wheel, like with a steering wheel or some kind of valve like that, this would be the effort force. Sometimes it's different, and then the resistance would be from the axle. So when we're trying to calculate the distances, the effort force distance would be from the center of the axle all the way out to the edge of the wheel, and then the resistance force distance would be the center of the axle all the way out to the end of the axle. So that's something to pay attention to. But sometimes, like in a car, the force of the effort comes from the drive shaft, which goes through the axle. So in that case, this would be the force of the effort, and the resistance comes from the street. So that would be the force of the resistance. So it's important to know which is applying the effort and the resistance. If you're trying to twist the wheel, then the effort is out here. If you're trying to twist the axle, like with an engine, then the effort is for in the axle. So there you have that. We move on. IMA for a wheel and axle. The ideal mechanical advantage is just using this formula. It's the same idea, except for now we're going to think of diameters and circumference. So circumference is 2 pi r. This is actually not written properly, so that would be pi times diameter. 2 pi r is the same thing as pi times diameter. So the the ideal mechanical advantage would be the distance of the effort force, which would be the circumference there. So pi times diameter. So that would we'll write that. So when we say that, there we have this. Really, all we're thinking of, because of the pi's, they cancel out. All we're really dividing are the diameters. So yeah, we have to know the diameter of the axle, and we also have to know the diameter of the wheel in order to get the ideal mechanical advantage. And so that's what this calculation is. They cancel out. So if we were to calculate the ideal mechanical advantage of this wheel and axle, we would say that we'd have to figure out which one is the resistance force and the effort force. So if we, there's two things that we could do here. There's two ways to get this. So if we did that ideal mechanical advantage as if the effort came from the outside, if we were trying to turn the wheel, so if this was the force of the effort, then what we would say for the ideal mechanical advantage would be dE, the effort, which would be 20 inches, divided by the resistance. If the resistance is coming from the axle, that would be divided by 6 inches. So this would be if the wheel was driving the axle. We were trying to turn the wheel so that the axle would move. That would be this one. And then we'd get 3.3 repeating, I think. 3.33. And if it was the other way around, if we, like the engine or something, was turning the axle, then the effort would be on the axle, and we'd switch these. So it could also be 6 over 20. It's important to know where the effort is coming from. So that would be different. So that would change the ideal mechanical advantage. If you're trying to change, if your effort force is here, then your ideal mechanical advantage is less than 1, which means it's kind of harder to turn to get this to spin. But if your effort force is on the outside, you would have an ideal mechanical advantage greater than 1, which means you turn this, and it would be easier to turn the axle, right? Because you're using the wheel. That hopefully should make sense. Moving on. So on this, wheel and axle AMA, the actual mechanical advantage. Remember, the actual mechanical advantage is just using the forces. So you have to actually perform the experiment. And the force of the resistance over the force of the effort. So use the wheel and axle assembly illustration to solve the following. Find what is the actual mechanical advantage if the wheel is driving the axle. So if the wheel is driving the axle, then that means the force of the effort is coming from the wheel. And then the force of resistance is coming from the axle. So we're trying to drive the axle. That means the axle is going to be resisting. So to get the actual mechanical advantage, you just take the force of the resistance, which is 200 pounds, and divide it by the force of the effort, iron feet, 70 pounds. And so we have that. And that's 2.86. 2.86. If it was the other, or actually, if we wanted to calculate the efficiency of this, remember we have to do, efficiency would be the actual mechanical advantage divided by the ideal mechanical advantage. It's like, this is the measured amount over the 100% amount. Remember IMA, that would be treated like the 100%, the theoretical. So there's the formula for that. It's times 100. So our actual mechanical advantage was 2.86. That's from measured forces. Our ideal mechanical advantage, I think, was 3.33. And if we divide those, is that right? Yes. If we divide those, we get 85.9% efficiency. It's never going to be 100% efficient. Yeah? Yeah? Okay. Moving on to pulleys. Actually, I think I'll pause this video. We'll make a part 2 for pulleys.